Okay. Yeah. Service mesh equals service mesh. That's my my topic. Down to the basics here. No LLMs and yeah, no complicated stuff. I hope. Uh, this is more of our journey. It's like a talk of our journey of connecting services. A problem actually, which yeah, was and is there for quite some time already. Yeah, something about me. My name is Sebastian Nickel. Everybody knows me as Nick. I'm a platform engineer at Nine since 2015, so soon there will be 10 years in January. And hobbies, yeah, I have a family. I love cycling outdoor, indoor, and wherever. And yeah, in electronics, I'm also a bit interested. The low-level stuff. Background, yeah, describing the problem. We have various services running in Kubernetes and on classic virtual machines. That's the ground layer, right? We have NKE, where customers can run their stuff. We have also, for example, vClusters, and we have databases, on-demand databases, which run on virtual machines. We have, like the most recent product, I think, is the key value store thing, which actually runs on Kubernetes and not on a VM. And what we want is basically, we just want to connect those services. And yeah, customers basically want that. What the problem about that is, for example, on our NKE stack, you can't predict the outgoing IP. That's not possible because, for example, when there's maintenance, we're actually replacing all the machines. They got completely new IPs, and the pods move over, and then the outgoing IP is a different one. So that's not really predictable. So like the classical firewall stuff really doesn't work. And then there's also deploy, I forget, where we also want to connect services from. I already said that IP restrictions are not really suitable anymore. And there's also, for example, in the database case, if you have a database, you might not want like the whole world being able to connect to the database. Maybe just your pod from your NKE cluster or your deploy application. So yeah, that's also a requirement. It would be cool if everything is basically like internal. And yeah, we can't provide this with the underlying network. That's just not possible. Like, for example, when you think of Google, you can create a VPC and you can use the same like IP range multiple times. We don't have that. We have a simple network, public IPs, connection from A to B, basically. That's a very simplified architecture of that, just so that you actually can have a look at it. We have a deploy cluster. We have the service cluster. Like if you have, for example, a product from us, Grafana, Tempo, or whatsoever, or KVS as well, the key value store instance. That's all running on the service cluster, on one Kubernetes cluster. Customers have their NKE clusters. We have databases running on VMs. And we also have like the classical managed service, where normal hosting applications, web applications are running on. Maybe they also want to connect to one of our on-demand services. And yeah, that was the issue, and still kind of is a bit, right? So we had the first solving attempt, and we're going back to June 2021. That's the time when we actually tackled that issue first. Back then, we had the whole database on demand coming up, put it on virtual machines. So customers ask, hey, I have an NKE cluster. Which IP should I put in? And we said, we don't know. They are changing all the time. So that project basically came up. And like, yeah, I will just do that. The projects we had a look at, Cilium external workloads. Back at that time, we only had a look at projects which actually were able to connect to VMs. So Cilium external workloads, we were already using Cilium as our service, like not service mesh, but our CNI solution. We had a look at Kilo, which is a WireGuard-based solution. Console back then, Kuma, and we also like had ideas about custom solutions. And link to the results, and that's the thing which I actually prepared here, but due to the mirroring didn't work. Okay. So I don't know, it might be a bit small. I also don't want to show everything here. It's more like that you see how we actually do those things. So for example, Cilium external workloads, we tested it, and as you can see, advantages and disadvantages. Like the main disadvantage, I didn't get it to work. Back then, 2021, it's all back 2021, right? Yeah, it's a pretty harsh one, to be honest. Nowadays, I think it would be different, but back then, yeah, yeah, we also have the issue that we, for example, want to connect multiple clusters to the same cluster, like the service cluster, for example, but we have multiple NKE clusters from customers. And for Cilium external workloads back then, you need to have a /30 subnet, which is basically used in that whole connection to the VM. And yeah, it wasn't really the one, or the solution which we were going for, I'd say. Then there's Kilo, a WireGuard-based solution. We had a look at, you basically have, I think, pods on the nodes, which act as the WireGuard proxy, and then stuff is basically connected in the cluster. And you can also have that on the VM. But one issue back then, right, was, for example, the VM always needs to connect to the so-called leading pod on the cluster, which is the leader for the whole WireGuard thing. And if that leader changed, you needed to reconfigure the VM. So that's a bit of an issue, because in our case, everything needs to be totally automated. There's no one doing something like I can type, right? That's not happening. Everything needs to be automated. And also, all these WireGuard-based solutions, back then at least, we always had a problem with managing networks. Like, you have those private networks, which you can use for that case, but then if you have multiple things connecting to the same, they shouldn't clash. So they need to be unique, and you need to manage that. And yeah. So basically, Kilo wasn't the one which we've chosen. Based on that, ideas for custom solutions, also based on WireGuard. I don't know what that was. It wasn't chosen. And then, another idea: public IPs with dynamic firewall rules. never really looked at. Basically, the idea was here that we have something running on the database server on the VM, like a software, which checks, hey, what are the current IP addresses of the Kubernetes cluster, and I adapt the firewall rules dynamically. That was the idea. Provides no encryption, right? That's a bit of an issue. It just takes part of the authorization part. And I think nowadays, when I would have a look at that again, the delay in some stuff might be a problem, right? So yeah. Console, also, we had a look at, don't read the first disadvantage, it's pretty harsh. Let's say console wasn't also something we did consider. Also because of the, you need to run console server for per K8s cluster and per VM, which is already quite some overhead. We didn't want to do that, really. And then was actually the solution I bet on. Yeah, there's Kuma. That's actually readable, right? And back then, or even today, Kuma is like that universal service mesh thingy where you can have multiple clusters connected to each other, and also VMs, which is down there, but it's quite big. Actually, that's the database VM. And back then, we had a look at how can you configure it? How would we actually do it? Because Kuma supports multiple meshes and multiple zones, so you need to find your desired architecture for that. And we came up with one mesh per organization and then one zone per K8s cluster and VM, which in the end means you need quite some types of load balancers, so you need quite some IPv4 addresses if you really want to get that going. So it's still cool. I actually built a POC with that, and I presented it to the team. And Kuma also works with so-called sidecars. Does everybody know what is a sidecar approach? You don't talk directly to the other application, but everything goes to your sidecar proxy. And Kuma is using the Envoy for that. And I presented that to the team. Also, the VM connection was working. And I was pretty proud of myself that I actually got that going. The thing was the overall, the overall opinion of that was, how the fuck is that complex? It's so complex. I mean, really, do we really want to go that way? And there were other issues. For example, the connection between control planes, like remote control planes, and the global control plane. I don't know if you've seen that. There is a global control plane in Kuma where everything is all the CRDs, where we define everything, and that's actually propagated to the remote control planes running on each cluster VM whatsoever. And the authentication between them back then and today still is only IP secure. So you need to know your IPs. If you want to have something better, you need to go enterprise. And yeah, connection to a service always has to use port 80. That was also interesting if you don't have like web service where you want to connect to. DNS is resolvable between meshes, but not connectable. Like if you have multiple customers, right, and then the DNS is resolvable. Yeah, it's interesting. And also another security related one was all CA certs and keys of all meshes are stored in every cluster. I mean, still it was or is stored or would be stored in our namespace. We have an own namespace on every NK cluster, but still you just don't want the stuff to be stored there. So yeah, I was proud of myself, but in the end, yeah, people said it's too complex, security is not good. Please go on. Yeah, and from their own service mesh solution based on proxies with Envoy, kind of nice idea. But given just the sheer amount of development time which would need for such a solution, we quickly went over that. And we also had a look at Nutanix VPCs. Back then, Nutanix is our infrastructure provider for running VMs, and they provide a feature, VPC feature, the same as Google, for example. But yeah, back then it was a bit of technical and also license price. We don't know how much it costs issue. Yeah. So overall, going back to the whole thing here, the results, yeah, we would have to manage subnets with those WireGuard-based solutions. Complexity clearly is too high with sidecar-based things. And if we want to do anything like come up with something ourselves, it's way too much work. Security-related concerns for Kuma, right? The whole secure as certificates and keys are stored everywhere. So yeah, project delay. We actually said, no, there's no solution yet in 2021, which we would, I don't know, we would like to use. So we don't know what to do. Let's wait for the problem to solve itself. Maybe some other projects will come up, maybe others will be better, or maybe even the problem will go away, I don't know. Yeah, that was the solution to that, 2021. And then some time passed. Actually, the issue was the problem didn't go away. So that was still, yeah, the thing. Basically, when customers were asking us, which IP range do I need to, or which IP do I need to allow on my database cluster or database, we always said you need to allow all the NKE networks because we don't know which IP your desired VM will have at some stage. Yeah. And then the second attempt, right? Problem didn't go away, so we had to, tackle it again. And that was quite wait, some days later, October 2023. And then, requirements haven't really changed. And actually, Pavel sitting over there took that over. Me being freed. Maybe I was also Kuma biased. I don't know. So it was cool that Pavel took that over. And back then, Istio seemed to be that prominent service mesh. It won the war against Linkerd or whatsoever. So we had a look at it. And results, well, it took us a really long time to get into that topic. October 2023, I said, I had a look 2 days ago when the ticket was actually closed and finished, and that was in December. So it roughly took 2 months to get us totally into that. I won't show you the internal documentation because it's huge. Pavel did a really good job there to figure out all the details. To sum it up quickly, Istio has a really high amount of CRDs, where I think you don't really know what is doing what. The documentation, also there's a high amount of documentation which you need to understand and how to configure things. And then we also had the spiffy Spire related issues. So if you have a sidecar-based approach, then all your packets are basically encapsulated with MTLS to provide an identity. And that identity is normally for the service account which your pod is executed with. So on the other side, you then know you have the identity, you know the service account, which is basically talking to you. And that spiffy Spire is a framework for creating trust relationships and stuff like that. And the format of that identity is was quite strict, right? If it was mesh.namespace.serviceaccount.something, I don't know. But in the end, we would like to have way more stuff encapsulated in that. like NKE cluster or like organization. We like to have more. And it was hard to actually, yeah, figure out how that's done. So overall, yeah, debugging with sidecar is horrible. I mean, I don't know if you've ever done that, but I think it's not great. Overall complexity is too high with Vista.io. So compared to Kuma, yeah, no change of results here. So yeah, and then yeah, we left it at this stage. So basically, yeah, project again delayed a bit. In the meantime, there was also a different problem. Like customers have NKE clusters and they have like their legacy firewalls at some place somewhere outside, and the problem stays the same. Which IP do I need to allow? But this time it's not 9 internal connection A to B, but connection from 9 to somewhere else. So static egress was the thing. July 2024, we implemented a solution to have like a static egress IP for NKE pods. You can select which pod should have basically or should talk to the outside with that IP via labels and or selectors basically. And that allows to connect the services outside with a static IP. It's also HA based, so whenever some node goes down, the traffic flows over a different node with having still the same IP. And yeah, but it needs an additional IPv4. And if you, for example, you have 3 databases per like environment, production, staging, and testing, but you just have one NKE cluster with different namespaces per environment, you would need 3 static egress resources, 3 IPv4s. Stuff gets pretty expensive, right? And yeah, that is a bit of a problem there. And it also doesn't encrypt the traffic. It's just routing in the end. So we had to see that this is not really a long-term solution to connect services in 9. It was not developed for that, but it works as a workaround for a bit. And then the third attempt to solve that. September 2024. Problem didn't go away, and this time on the plate, my friends. Traffic mesh, Kuma, again, Linkerd, and Istio ambient mesh. So yeah, I was put back into place for that. I don't know, I guess. Yeah, was not a very prominent topic in the platform team. Yeah, traffic mesh, I just had a look at it. I'm using traffic personally, that's why I had a look. It's not really, I didn't really test into that because the documentation already revealed that the connection to external VMs is not possible. It uses proxy pods on each node instead of sidecars. It's cool. And they like if you have a look at the documentation, the architecture is very lightweight, and that's always what I love. Like if it's easy to grasp and understandable, that's cool. Yeah, but it's more meant to be used on one cluster and not like over multiple clusters. Yeah, I just had a look. I just wanted to see how did the project evolve, what was updated, and our old desired architecture still like holds true. 1 mesh per organization, 1 zone per K8s cluster and per VM. That's already what we had back then. Interestingly, what I just showed you before, I forgot that it exists, so I thought about the whole thing again. I came up with a solution, and then someone told me, hey, we actually had a look at this already. And I compared, and I said, yeah, still holds true. Good stuff. There's still IP-based authentication between remote control planes and global control plane, aka you need to go enterprise. We would need quite some additional IPv4 addresses, and the complexity stayed the same. So overall, some things got fixed actually, like the port always needs to be TCP/IP80, for example. That's not the case anymore. There's a workaround for that, or like a feature for that. So it evolves, but still complexity, I think, is quite high. Linkerd, yeah, Linkerd always, I think, like what they announce or what they say always, their statements is everything is basically very easy to configure, and that's also something I like. So you have no global control plane like in Kuma and Linkerd, but every cluster has its own control plane. That's also cool. Like if your global control plane dies, in that case, everything is still fine, right? To connect between clusters, a gateway component is needed. Obviously, they also use proxy. They don't use like Envoy. They have their own proxy coded. And it's also but MTLS, sidecar approach. So yeah, sidecar approach, basically. What was interesting is the concept of service mirroring. So if you don't have a global control plane, how does the source knows, how does the source know where to connect to, if there's no global registry of services. And they have like components which connect to the other clusters and check Kubernetes services for annotations. So if you say on your target cluster, hey, actually you can connect to that service, you annotate it with a specific string value, the component on the source will detect it. They copy over the Kate service, right? But they replace the endpoints. I don't know if you know about endpoints of Kubernetes, which is those are basically the IPs for the service, and they replace it with the gateway component of the other side. So whenever on the source you connect to that service, you will connect magically to the remote gateway. The problem with that is it's called service mirroring, and it exactly does that. Mirroring means one-to-one, also namespace-wise. So actually they expect that you have the same namespaces set up on all the connected clusters, and that's not the case for us. I mean, especially for customers' clusters, we don't know which namespaces they will come up with. So that doesn't really fit into our concept. I looked a bit into the Go code, and yeah, it was not really changeable because the whole system is also established in the identity trust. Like again, identity is based on string, right? And that actually was, really baked into that. Let's call it like this. Yeah, and then another story. I did not get the multi-cluster feature to work, and the thing is, Linkerd is really, I mean, the whole setup is really easy. And I'm saying here, thanks Bitnami for the learning. The thing is, how I tested is, I just set up like an NKE cluster, my service cluster in my demo, and then another NKE cluster for the customer. And I just wanted to get a connection from client to a Redis pod running on the target. And to set up Redis, I used the Bitnami Redis Helm chart. Basically, just I can type Helm install, And the thing is, everything went fine. And by default, it starts like a primary node or primary pod and 2 secondaries, and they connect to the primary. And that looked really well. Everything was fine. But then to get those pods into the service mesh, you again need to annotate them. I think annotate or label, I can't remember, but you need to do something. Then those pods get restarted and the sidecars get injected. And when that happened, actually, these secondaries couldn't connect anymore to the primaries. It wasn't possible anymore. So I digged a bit, like, what's going on? And then I said, actually, that's not my task to figure it out, because if I still have the primary, that's enough for my client to connect. I don't care about the secondaries, right? So yeah, in the end, I debugged a lot there, and I didn't figure it out. I couldn't connect from the client to my primary pod there. And I said, I don't know, screw it, go to the next project. There's anyway the service mirroring thing, which doesn't fit, so it's not that bad, right? And I went to the next one, which I will show you in a second, the Istio ambient mesh. I did the same thing, and the same thing happened again. I couldn't get it to work, and so that's not the problem of the service. That's a problem, I guess, of mine. And the cool thing about the Istio ambient mesh, though, was in the logs there was, I can't connect to. Do you have a network policies established? And that rang the bell. That rang the bell, right? And I would have never thought about network policy. I guess you did, okay? I didn't. And then I checked the Helm chart, and yes, by default, they establish a network policy. And that network policy, I thought, why didn't it work? Well, if you have sidecars, your sidecars are talking to each other on different ports. And then the network policy doesn't match anymore. So same thing, yeah. I disabled the network policy and went on with Istio ambient mesh. Yeah. So yeah, Istio ambient mesh, like I don't know, I don't want to call it more modern service mesh, but it's supposed to be like sidecar free where possible. It's also way easier to configure. I mean, really, like configuration-wise, it's way easier than plain Istio. Yeah, the network policy led again to issues. I already told about that. But for our use case, if you want to connect from a source cluster to a target cluster, you need a waypoint proxy, because only the waypoint proxy, it's an envoy, is able to do all the MTLS thing. It's not possible otherwise, and to be honest, till I found that out, it took some time. Because there is still a lot of Istio documentation which is targeted to plain Istio, And there's also the ambient mesh documentation. And there are so many GitHub issues where I couldn't figure out, hey, is that ambient mesh? Is it possible at all? And in the end, I found it's actually only possible with the waypoint proxy. Yeah, the documentation was not always clear. And the waypoint proxy was not really transparent for customers. And that actually falls back to the whole network policy thing. Because if you want to establish the whole thing quite transparent on a client cluster, and they have network policies, you might just be screwed, right? Because those network policies, they suddenly don't work anymore just because your client is now part of the mesh. So we said, that doesn't really work. It's not really, you can't just like roll it out. And then we started Dream again, right? Wednesday is our office day, so we sit all together and then like, hey, actually, can we just come up with our own service mesh? Is it that hard? Yeah, you know. And that whole discussion quickly, actually, it wasn't that long, finished up with statements like, yeah, too much to implement. And we wouldn't do the same way as the others did. I mean, there were no new ideas, right? Because the other ideas are already great. It's just complex. And yeah, there's also a video. I actually checked on YouTube. Did anyone else ever implement their own service solution? And Monzo Bank from Great Britain, they actually did it back then when there was no proper service mesh. And it was really cool. The presentation was cool. But in the end, obviously, someone asked, hey, would you do it again? And he was like, no, I wouldn't do it again. Because nowadays, there's so much stuff on the market. So yeah, only negative stuff here. That's how I felt. I can actually remember I was here that was like during the last Tech Talk Thursday, and I did all those investigations, and I talked to one, and I was really depressed. I said, there is nothing on the market which can just like solve our, I think, in my opinion, quite simple use case. Then whispering voices. Why is it called whispering voices? Because on Wednesday we sat here, I was complaining, I'm German, right? There's no service mesh solution which just fits our need. And then from the right, and there's where Cyril sitting, he always said, tail scale. And I was like, okay, yeah, I know it's a WireGuard-based solution. Maybe we have to manage those subnets again, right? That was always something I was a bit afraid of. And does it really, for example, provide an identity? Because normally WireGuard solutions, they don't provide an identity. You have a proxy and something talks via that proxy. But yeah, I was down, so who cares? And then we tried the Tailscale and the Tailscale Kubernetes operator. And Tailscale, I don't know if you don't know it, but it automates just WireGuard mesh networks. It's a full mesh. There's a central control server, and it just works. And that was basically already the point where I was sold. Because like given all the things we tried out before, and then it was so easy to get something up, that was a really great thing. Because I don't know, you have to add an annotation to a Kubernetes service, and then like on the source, and then the same thing I think on the target, and then allow it in the policy and done. Like with all they also provide a magic DNS thing, so every registered device, node, machine gets its own DNS, and then you can just do it. No additional IPv4 address is needed because it uses what the host has a public IPv4, and that's what it's using already. So really cool. Annotating Kubernetes services, I already said that. The client code is open source. The control server code is not. Allows for magic DNS. And there's the Headscale project, right? There's the Headscale project, which is the control server open source implementation as an alternative control server. And yeah, the funny part about that is that I think the main developer of that works for Tailscale. Now, it got hired, yeah. That's an interesting thing which we will see in a bit. So yeah, it felt really good to be back in the game. That was really great. And yeah, we tested everything. And was it too good to be true? Well, the Tailscale Kubernetes operator actually doesn't work with Headscale. And the reason for that is the operator talks to the control server. That's cool. That's what Headscale implements. But there are, I don't know, 2 or 3 API calls actually, which go to let's call it proprietary API at tailscale.com. 2 or 3, right? So people try to solve that issue. sites. So let's start with the Tailscale side. So they went to Tailscale. I think they even did a PR, or I don't know, maybe only an issue. And they said, okay, here's that code. They basically implemented it, or came up with a Go interface saying if you want to talk, that's the normal Tailscale implementation. There is a headscale implementation. And the answer was, we don't want to have any headscale related code in Tailscale, which is fine, I'd say. It's reasonable to do so, right? You want the stuff, you keep your stuff clean. And then there's the other side. There's the headscale side, right? And there it is more about could you just implement those REST endpoints for those 2 to 3 API calls? And that guy was, or the answer there was, that's not really headscale's thing to do. We have gRPC, we implement a control server, that's not our part. So if you have something which can't directly talk to each other, what do you come up with? A proxy, right? So basically the idea was to come up with a proxy which implements those REST API endpoints and then passes that in gRPC format to headscale. And besides that, some things are also hard-coded in Tailscale. For example, that whole, the endpoint where the REST API is, that's hard-coded. You can't change it. So that's something, which need to be changed. And that's actually the solution we are now going for. Come up with such a proxy, open source it, and then try to convince Tailscale that the endpoints can be customized. That's basically the idea. I mean, the code changes on Tailscale side are not that hard, I think. It's more of a, are you doing it or not, right, thing. And we need to integrate then the whole solution into our self-service concept so that it can be fully automated. Where are we today? The proxy is implemented, actually. It's not yet open source because we said we just want to get up with everything and then test it, see if it works, and then we can still open source it and try to get stuff merged to Tailscale. We have an API concept of connecting services. It's a very easy API concept. You say basically from to. And then you, from is a Kubernetes cluster, and to, for example, the KVS, the key value store instance. And then all this stuff runs in the back. And you get a magic DNS, and then you can just connect. There's also the policy concept, Headscale or Tailscale uses tags to identify, or you can add tags to devices. And then you can say tag A is able to connect to tag B on port whatsoever. We also want to have that fully automated, so we wrote a reconciler, policy reconciler, which does that. Staging setup is also done, and we have quite some code written. What will be next? The magic DNS setup for Kubernetes. That's actually what I'm currently working on, because what I learned yesterday or 2 days ago, I don't know. I always thought there is that global domain for Tailscale, because Tailscale by default uses ts.net, and that's also hard-coded. You can't have anything else, right? And I always thought there is ts.net is hosted somewhere, but it seems like the DNS thing is always done on the client. So when you have a Linux VM, you do Tailscale up or so. It actually, we don't know how. We tried to investigate, but 5 minutes weren't enough. It hooks somehow into systemd thingies, and then basically provides you with the correct DNS. And the same for Kubernetes. We have core DNS, and then you have the domain, and that domain, all the requests for that specific domain will be targeted to a name server, and that name server gets controlled by the headscale control server. That's how it works. Allow API resources to be targeted. So in our concept, whenever there's something a target or wants to be a target, it needs some code to be implemented. Test our whole setup. Well, good. And build the production environment as well, and then see if really everything works, and then open source the proxy and try to get stuff working. Yeah. Release it. There you go. So that's it. That's our journey of connecting services and where we are. Any questions? Thanks. No questions? Everyone say,
I have a lot. So.
Okay. So maybe the others can leave. And no.
So the second time you didn't test some external workflows. I'm a silly
No.
So I'm curious.
I was expecting that. First thing was, if I remember correctly, for some feature you need to have Cilium Enterprise.
This is beta. It's fine. This works in open source as
Maybe, I don't know. Yeah, no, well, to make it quick, we didn't have a look at it again, I think, right?
The Cider clashes were the issue.
Cider clashes as well, maybe.
Yeah.
I don't know.
Okay.
Might be.
It was an enterprise feature back then, at least. Like if we have multiple clusters, they have the same cluster Cider.
Yeah.
And if you want to connect these, then you need enterprise.
Yeah, that would make
And we got a quote, and we said no.
That's also the thing. Like we're not cheap asses, but the thing is, you need to basically, if you pay that, you need to make your products a bit higher, like higher priced, right?
Yeah.
That's the thing.
Yeah.
And for such a connection, for example, you provide products, a key value store, and you want to provide your customers a very easy way to connect. Isn't that like, wouldn't you just expect it that it works, or would you actually pay like an additional fee for that? I don't know.
I pay for enterprise, so I have a bias to that. That's why.
You're working for Rush, right? So.
Also, the use case is very different. And damn it, I forgot the sales. Okay, I wait for other people for questions. I'll think again.
Are there other questions? If not, I'll get a beer. 3, 2, 1. Okay, thank you. Oh, in the last second.
I totally understand the problem and why you want to solve it, but why haven't you moved the databases to the same cluster that deploy your apps?
It's not only like on-demand databases are standalone. They are standalone. You can use your database from NKE, from Deployo, like the same database, right? And that's already it. I'd say. Right? You need it's just a database instance you want to connect to. You want to have it secured and encrypted. That's basically the use case. Like, I don't know if you ever worked, like, for example, we work with Cloud SQL from Google, and there you have a private network. I think like by default, a private network underneath your Kubernetes cluster, your GKE cluster can just connect via private IPs. No one can access your database from the public, and that's a pretty cool solution, though, right? And that's something like what we want to have as well. Yes.
You mentioned that you work with AWS and GCP and Azure, right? So do they not offer? I mean, since you have to run one of these Kubernetes clusters there, do they not offer any of this solutions for this problem?
No, we actually like that solution I was talking about is completely for 9. That's just for 9. We also offer like a managed GKE product, but there Google solved it for us, right? But here, like at 9 in our data centers, it obviously wasn't solved just by someone else. Dan.
Cloudflare. Have you considered that as well as an option? Basically, you could terminate MTLS towards there and then assign that to work.
But if we talk about MTLS, we again have sidecars, right? And
Depends how you do it. You could do it at the node level.
okay. What about identity then? Yeah. Okay, that would actually be similar to what we have now. Maybe. But is that Cloudflare? Is that something?
We can talk about
it. It's also like you're using an infrastructure from someone else, and we are a bit, let's say, biased with other enterprise solutions which we work with. If there's a problem, you need to talk to support, right, and get it solved.
Yeah.
And to be honest, in my opinion, whenever it's possible to circumvent it, do it. Really, if you have control over your own infrastructure and you know how it's working, it's the fastest way to deal with an issue, I think. So we are always a bit like, can't we just do it ourselves?
And there's the compliance question which some of our customers just don't want to have in between. So
we talk later.
yeah.
Cool. So thanks again. See ya.